Hi guys, welcome back to my channel Chai and JRF by Eva. So in this video we will be covering the second part for square of opposition. So today we will be covering the our A and E type of proposition that is termed as contrary to each other. So let's try to understand what type of this square of opposition immediate inference is. So let's get started. In order to understand the concept of square of opposition, I want you to go through the video of distribution. So it is necessary for you to understand the concept of distribution in order to understand the square of opposition. So this is a type of this is a topic that I made a separate video on distribution. So it is a recap of that video. I hope you can recall it. If you have not watched that distribution video, I prefer you to go through the distribution type video so that you can understand the concept of square of opposition, immediate inference in a better way. So let's get ahead with our today's topic, that is contrary A and E. So this is a part 2. Before that we did contradictory type of relationship between the categorical proposition, but today we will be focusing only on A and E type of proposition. It is termed as contrary type of relationship in a square opposition. So let us try to understand like how do we draw a conclusion from such type of premises, right? So what is going to happen, so what kind of inferences we will be drawing from these is, so when we say that A and E type of propositions, they cannot be true together, right? But they can be false together. I know this might sound tricky to you right now, like what am I telling you, but trust me, it's easy. So let us have a look at an example and try to understand what's happening in here. But always remember that they cannot be true together, but they can be false together. So now let's have a look at a certain example in order to understand this concept. So let us take this example for A and E type of proposition, right? So we know that A type of proposition, it will include all types of subsets in a single element, right? So here we are saying that all apples are green in this basket. When I'm saying this, and so let us assume this type of basket. So it's having all type of green apples in this basket. Now let us imagine a different type of basket that's having red type of apples in it. But what will be the proposition? No apples are green in this basket, but they are which color? They are of red color. So we have taken these two types of premises here, that is based on A and E type of categorical proposition. So now let us try to understand what's happening in here. So you have seen the examples here, like for the categorical proposition. So if I tell you to find out a certain conclusion from these two premises, what will you say? You will be left entirely clueless. You will say, oh sorry Eva, I don't know what will be its answer. So right, that's why we use the concept of square of opposition in order to draw inferences, in order to draw the conclusions, right, out of certain premises or certain our categorical proposition type of statements. So right, so in order to understand this concept deeply, so we have taken these two examples. Okay, so now moving ahead with this example, like what's happening here. Okay, so now let us see, when I told you that these cannot be true together, cannot be true together. Why? Like why cannot these two be true together? Simply look at here. On one hand we are saying all apples are green in this basket. On the other statement we are saying that no apples are green in this basket. Is it making any sense? Not really. So that's why we can say that they are not true together. Why? Because these statements are like they are giving illogical inferences or illogical conclusion. We are not coming to at any kind of conclusion, right? On the other hand, we are saying that all apples are green in this basket, right? On the other hand, we are saying no apples are green in this basket. So which type of basket are we talking about here? So we are not sure about it. That's why they cannot be true altogether. So, but I told you a certain condition, but they can be false together. What does it mean when they are false? So the concept of falsifying and validating the truth of a statement, it is based on how do they act in real life. Are they based on truth? Are they based on real life situation or facts or not? So if they are based on truth and real life evidences, so we can say that the statement is true. If not so, the statement is false. Okay, so now let us go through certain types of conditions that we have for A and E type of proposition. What type of conclusion are we going to have? Right, so I think let's start with simple true and false one. Right, we did one concept in contradictory video as well. If we are considering one conclusion at one time, so the other one has to be false. That's how we are going to come to a single conclusion, right? So it's happening in this same scenario as well. So either we take this as true, so it will become definitely false, right? So this is the condition for your very first situation. Similar to this, right? Similar to this, what are we going to do here is, if we are considering E type of proposition as true, like yes, we are taking like no apples are green in this basket, so which means that we are taking this basket, which means that the apples are red in this basket. So what will happen? So this type of proposition, it will become falsified by itself. So that's the rule, right? So now we here understood two types of situations for your A to E contrary square of opposition relationship, right? So when I say let us discuss this false and false type of situation, what's happening here is, we can say that they can be false together, but they cannot be true altogether. The reason being, so let us say we have another basket, right? We have another basket. It has 50% of the apples are green and 50% of the apples are red. So what's happening here? We are not saying that all the apples are red, right? Nor the no apples are red, because we have 50% of both the colors in the same basket, right? So we are having both types of colors in the same basket. So we cannot say that all apples are green in this basket, no apples are green in this basket. So what are we saying here is that both the categorical propositions are false at the same time. So we discussed this situation as well, right? So now let us try to understand this type of relation. So what is happening here? What exactly is you? You must be wondering, Eva, why did you write you here? What does it mean? So it means that undetermined. Undetermined means we have not enough knowledge, we don't have enough information in order to come to a single inference or a conclusion, right? When we say that we don't have enough information, or we can say that data inadequate, when we say that data is inadequate, we cannot come to a single conclusion. That's why we use this term as U, which means unidentified, right? So now what is happening here, we are not able to understand. Let's simplify it in simple terms. Okay, let us consider this scenario where A is false, right? I am saying that all apples are green in this basket, right? So when I'm saying that all the apples in this basket are green, and it is false. In truth, the apples that are in your basket, they are not green. What are they? They are red. Are you sure about it? Not really. We are not sure about it, right? Because what's happening here? We have to add the concept of sum as well, right? So all is different from sum. I have told you like why like all distributes its only subjects, not its predicate, right? So what's happening? All apples, they are getting distributed, so it is the subjects, and in this book this is your predicate, and it is not getting distributed. So what I'm trying to tell is, we are not sure that either all the apples that are in this basket are green is true or not. Why? Because we are having the concept of sum as well, right? So we can say that when this is false, we are not sure about this. We don't have enough data. What about the, can we say this like no apples? Like, are there some apples that are green in color or not? So we are not sure about it. That's why we use this type of undetermined relation that we are finding between these two categorical propositions, right? So now let us see this type of categorical proposition. So what's happening here? When are we saying that no apples are green in this basket, right? So meaning that no apples that are present in this basket are green, meaning that all the apples are green. Is it true? Are we definitely 100% sure that in this basket, like all the apples are red or green? We are not sure about that, because we could be having a possibility of having two colors as well. So that's why we are not sure about it. When we are sure about a certain fact or incidence, right, or event, what are we saying? We are using true here. So true means it is definite. When I say that A is true, means that it is 100% definite that all the apples in this basket are true. That's how it defines the concept of definite, right? Which means that with 100% surety we can say that all apples that are in the basket are green. So that's why we have used this true. And also when we say that these premises are false, it will lead to us data inadequate conclusions. So we cannot draw certain inferences based on inadequate data. So that's why we say that we cannot define a relation between A and E. If A is false, your E will be undefined. Same goes for this scenario. If your E is false, your A will remain undefined. We will not have a one particular set of conclusion for this type of relationship, right? So go through the video again. If you feel like you are getting stuck somewhere, I prefer you to watch the video again and practice solving this by yourself. You will be able to get it, like what did we do. So take these examples and try to try to solve it by yourself, like what we just did. So that was all about this video. Let us meet in the next video for a different topic that will be based on alternation type of relationship in the square of opposition. So that's it for today's video. Thank you for watching.